Hey guys, what's up? It's been a while, but here we go. We're getting right back into the swing of things, and let's get the show on the road, guys. Let's go ahead and take care of business and do the first summer assignment here. All right, so let's do these examples. So it says, let's see, it says point P is negative 1/5. That's the x coordinate, and it says y lies on the unit circle shown below. What is the value of y? So hopefully you read all this stuff here. Well, actually, there's not much to read, just the unit circle, right? So we know that the radius has to equal 1. So because we know that, we can see that I always have a triangle with a hypotenuse of 1. If you can see that triangle there. And yeah, I could have done a perpendicular to the y-axis, but always do your right triangles perpendicular to the x-axis. So I already know that the x value is negative 1/5. So I need to figure out what that y value is. So what you're going to do is you're going to do square root of negative 1/5 squared. I guess you don't have to put the negative there if you don't want to. Plus y squared equals 1. Right? So now we're going to square this guy, and I guess you don't have to do all this work. You can just go ahead and just do 1 minus the square root of 1/5 squared. So we have 1 over 25 plus y squared equals 1. Subtract. So y squared equals 1 minus 1 over 25. Square root. So y equals the square root of 1 minus 1 over 25. So I'm going to turn that 1 into 25 over 25, guys. So 25 over 25 minus 1 over 25. So now we have square root of 24 over 25, and then so we're going to have the square root of 24 over the square root of 25, and I believe the square root of 24 is just going to be, what's that? Let's see, 8 times 3, and then 8 breaks down to 4 and 2, and the square root of 4 is 2, so we're going to write it as, where did it go? As 2 square root, let's see what I have left. 2 times 3 is 6. 2 square root of 6 over 5. And there it is, guys. And that's it. Yes, I realize that you could always... Oh, okay, hold on. It has to be negative. Because I'm in quadrant 3. So put a negative in the front. And yes, I realize you could have done it immediately, guys. You could have just put a negative in the front and then the square root of 1 minus... negative 1/5 squared, and that would have given you this answer immediately, negative 2 square root of 6 over 5. Now, I prefer that you do these by hand, guys, and not use a calculator, but if you wanted to use a calculator, it should work immediately. So let's just see. If I were to do square root of 1 minus, and then in parentheses, I can put negative if I want to. I don't have to, but if you want to. And then get out of there and put a little square on it. And then if I push enter, 2 square root of 6 over 5. I prefer that you do it by hand though, guys, because this is simple enough that you can do it by hand. But it's up to you. Well, okay, try to do it by hand. Because, why not? All right, next one. Given the following point, half square root of 3 over 2 on the unit circle, find the angle to the nearest tenth of a degree if necessary of the terminal side through the point 0, 360. Okay, well, this is a perfect coordinate, guys. And yes, I know we're right here, 1/2 square root of 3 over 2. So the angle is 60 degrees. But I want you guys to see that you could have gotten that angle no matter what. So remember, this half is like an x coordinate, and that square root of 3 over 2 is like a y coordinate. And we talked about why that is, guys, because cosine is x divided by your hypotenuse, and the hypotenuse in this case is your radius, which is 1. So x divided by 1 is just x, and then sine is opposite over hypotenuse. So that's your y divided by your radius, which is 1. So y divided by 1. So yeah. Okay, sorry guys, I had to look at my phone real quick. All right, so how can we get these values? Well, we already know that cosine of some angle is going to give you a half, and we already know that sine of some angle is going to give you a half as well. I mean, square root of 3 over 2. Yeah, why am I'm all over the place today. All right, so having said that, guys, if I just write cosine, arc cosine of half, you're going to get 60 degrees. And if I do the same thing and I say arc sine of square root of 3 over 2, you're going to get 60 degrees. And as evident, let me show my calculator. So here it is. I notice that I'm in radian mode at the moment. So I'm going to click menu. And is there a settings? I guess I'm going to have to go to the home screen. 5, settings, document settings 2. And then the radian one, put degree. Enter. And then click make default. Okay. Okay, now go to your current document. Okay. Well, I guess I made a new one there. It's all good, guys. And then I go trig, and then arc cosine. Come on, buddy. Arc cosine of half. I'm going to put, yeah, I'm just going to go 1/2. And I push enter, and there it is, 60 degrees. If I push trig and then arc sine, square root of 3 over 2, square root of 3 over 2, and I push enter, and you get 60 degrees again. So no matter how you do it, guys, you're going to get 60 degrees. So there it is, theta is 60 degrees. You can actually say theta there, theta there. Theta is 60 degrees. Of course, that requires more work. If you already know it's a perfect coordinate, you can just go right into it. But question example 3 here is not a perfect coordinate. It says, given the following point on the unit circle, find the angle to the nearest degree. So I think the best way to do it, guys, is to do it with reference angles. So before I even start, this is not to scale. Here's my unit circle. I see that my x-coordinate is negative and my y-coordinate is positive. So I'm somewhere in quadrant 2. So if I do arc cosine of square root of 3 over 3, this is going to give me your reference angle. So the reference angle is this guy right there. So let's do that real quick. And it wants it to the nearest tenth. So I'm going to go my calculator and I'm going to put arc cosine. So trig, arc cosine, and I'm going to put square root of 3. Square root of 3. And I'm going to divide that by 3. I'm going to push enter. Oh, that helps. Control enter. And there it is. So I get, what was it again? 54.7 degrees. 54.7 degrees. All right, so that's what this is right here. That is not your angle. So if I do arc sine of square root of 6 over 3, it's probably going to give me the same thing, guys. So here we go. I'm going to do arc sine. So trig, arc sine, square root of 6, and then move to the right, and then divide by 3. And it did it to me again. Control enter. And there it is. Now, I know what you're saying. Why is sine or arc sine giving you 54.7 degrees? Because it is a positive number, guys, and it's giving me the very first hit. And the very first hit is this one right there. And we'll notice, yeah, that's 54.7 degrees. And it's 54.7 here, and it's 54.7 there as well. So it's giving you the first hit, guys. So this is not my answer. It's not 54.7. I want this angle right here in blue. So how do I find that out? Well, I know that the distance between, I know that half a revolution is 180. So all I'm going to do is take that reference angle and subtract it from 180. So 180 minus the 54.7 degrees is going to give me my answer. So I'm going to go 180 minus, that's not 180, minus, I scroll up, push enter, and then enter again. And there it is, 125.26, so you're going to round it to 3. 125.3 degrees. And there it is, guys. It really is that simple. And yeah, it's overkill. I'm showing you a whole bunch of different ways. So here we go. Make sure to read this when you get a chance. All right. So it says, find all angles that satisfy the equation below to the nearest tenth of a degree. So before, it says all. Satisfy, find all. It says all. Let me go back to red because it's my favorite color. What's my favorite color when I'm writing notes? So in the unit circle, sine's a y value. So sine, let's see, quadrant 3 and quadrant 4. So you have two answers. I want this angle, I'm going to call that theta 1. And I want this angle, and I'm going to call that theta 2. So what I'm going to do, I'm going to find the reference angle. So the reference angle is this guy, and you can see it there in blue, guys. So I'm going to go ahead and, to find the reference angle, you just drop the negative. So I'm going to put drop negative to find reference angle. All right, so here we go. Theta is equal to arc sine of square root of 24, square root of 24 over 7. So I take my little calculator, and I'm going to type that in. So I'm going to go trig arc sine, and I'm going to put square root of 24, so control square root 24, and I'm going to divide that by, was it 7? Yeah, it was 7. Divide that by 7. I'll push control to give me a decimal there, and I got 44.4153. 44. Short-term memory. 4153. 4153 degrees. That's my reference angle. That's this guy right here. All right, so to figure out the first angle, so I'm going to write theta 1. It's 180 plus the 44, so 180 plus the 44.4153. And then to figure out the second one, you can do 360 minus the 44, or that's the best route, I think, in my opinion. So for theta 2, I'm going to go 360 because that's a whole revolution, and I'm going to subtract 44.4153. So there we go. That's going to give me both answers, and then we're going to verify that that does give you the square root of 24 over 7, or the negative one there. So I'm going to write, so here we go, 180 plus that answer there. So 224.415. 224.415. I'm going to store this to A, guys. Oh, I put a plus. Oh, I'm going to store that to A. And then 360. So I'm going to click on, because I want to show you guys something in a little bit. So control store, and I'm going to put A. Enter. All right, and then I'm going to do 360 minus, and I'm going to subtract the 44. Push enter. 315.585. That's my second answer. 315.585, and I'm going to store that to B. So I'm going to go back, and I'm going to store this. So control store, and then put B. Enter. All right. So why did I do what I just did? Because I want to find out. I'm going to find out what this number is. So look, what that number. Obviously, it's a number, right? It's square root of 24 over 7, but negative. But let's figure out what that is in decimal. So negative square root of 24. The 2 for some reason is not coming out when I punch it. Divided by 7. Control enter. So it's negative 0.699. So if I push sine and I push that angle that I got, A and B, so sine A, and I push enter, I better get that value. And there it is. So if I push sine again and I push B, I better get that value again. And there it is. Yay, it worked. So good job, guys. If it says run to the nearest tenth, I guess I haven't finished yet. So run to the nearest tenth is, let's see, 224.4 degrees. Theta 2, 315.6 degrees. And there it is. That's it, guys. All right, let's see. Find all angles, theta, that satisfy the equation below to the nearest tenth of a degree. All right, before I continue, I see that it's tan. Remember that tan is y divided by x. So you are only negative in quadrant 2 and in quadrant 4. So again, I'm going to find my reference angle. So I'm finding this guy right there, and I'm finding that guy. So to find your reference angle, I'm just going to do arctan of square root of 26 over 6, and we're going to see what that is. So I'm going to go arctan, control. Nope, not control. Nope, get out of there. Sorry, guys. trig, arctan. And if you feel like I'm going slow, I apologize. It's just that it's different when you're typing on a computer screen here. And it was square root of 26 over 6. Okay, so square root of 26 over 6. Control Enter. That's my reference angle. So that is theta r equals 40.3591. That's a degree. That's not the answer I want. So since that's my, man, I'm going everywhere here. Since that's my reference angle, I'm going to subtract that from 180. So I'm going to go 180 minus that answer here. I'm going to push enter. So 139.6 is my first answer. Theta 1, 139.6 degrees. All right, I'm going to store that to A, guys, just like I did earlier. So control, store, and I'm going to push A. And then to get the second one, you don't have to do 360 minus that. You can if you want, but notice that these two make a linear line. So I'm just going to add 180 to that. So I'm going to go plus 180. And I'm going to store that to B. So control, store, B. Look, I pushed B, guys, but it doesn't come out. Enter. So there it is. So now I have it stored in B. So if this is true, so first let's find out what square root of 26 over 6 is. So square root of 26 over 6, square root 26 divided by 6. Thanks a lot, calculator. 0.849837. All right. So that's the value that I should be getting when I put in tan of A and tan of B. So tan of A, push enter, and I did not get that. Oh, yeah. Okay. Sorry, guys. I made a mistake. I did not make a mistake. I just didn't realize there's a negative in the front. That's what we want to get. So we're going to get the negative. Oh, man. I'm sorry, guys. It's been a while. So there it is. And then let's do tan of B, and I should be getting the same thing. So yes, I did get that. So, because it's negative, that's what I wanted in the beginning. Oh, man, Chavez. All right, so there it is, guys. Hopefully you don't frown upon me and give me a thumbs down just because of that. Let's continue the good show. So this one says, show the position of the terminal angle and then find the exact value of the function tan 3 pi over 4. So, all right, no big deal. Here's my unit circle. 3 pi over 4, guys. Here's a big hint. That integer is 1 less than 4, so that means I am in quadrant 2. So it must be this one. In quadrant 2, the x value is negative, square root of 2 over 2. The y value is positive, square root of 2 over 2. And then y divided by x, well, they're both magnitudes are the same, so that means that I'm going to get a 1, but negative 1. So tan, don't put arctan, tan of 3 pi over 4 is nothing more than negative 1. And there it is, guys. And I guess let me take a quick sneak peek so you guys can see how it's going to look on Delta Math. So let's do that real quick. All right, guys, here's that same question. They want me to find tan of 3 pi over 4. So I take this guy here in green. It starts at 0, and I go to 3 pi over 4. So 3 pi over 4 is going to be in quadrant 2 because it's more than pi over 2, but not quite. And remember, these are perfect. So look, that's pi over 6. That's pi over 4. That's pi over 3. That's pi over 2. Then that's the next one's 2 pi over 3. And then the next one, that one must be 3 pi over 4. So I let it go. And then the exact value, well, it says tan. Tan is y divided by x. The x and y coordinates are the same. So the magnitudes are the same, but the x is negative, the y is positive. So I'm going to have a negative 1. And then I just submit. And yes, and there it is, guys. So hopefully, yeah, pretty straightforward. All right. All right, continuing the show. So read that when you get a chance. Yeah. So here we go. 30, 60, 90 triangles, 45, 45, 90 triangles. So heads up, guys. Delta Math likes to do these questions by doing something called comparing or setting up a proportion. And what they're doing is they're setting up your basic proportion triangle, the 30, 60, 90 with one of the small leg being a 1, the hypotenuse being 2, and the long leg being square root of 3. We're not doing that, guys. I think it's just better just to go right into it as 30, 60, 90 and show you the properties. N, meaning the small leg is N, the long leg is N times the square root of 3, and the hypotenuse is double the short leg. So knowing that, this 60 degrees aims, this is your long leg. And we call these legs because the longest side we're going to call hypotenuse. This is only for right triangles. If it's not a right triangle, then we just call 3 just sides. So there's my long leg. So my long leg is square root of 6. So that means the long leg behaves with this expression. So the short leg times the square root of 3 is the square root of 6. I currently want the short leg. So that means I want to solve for n. So all you got to do is divide by square root of 3, divide by square root of 3, divide by square root of 3. Those go away. So the laws of exponents takes precedence here. Square root of 6, square root of 3, they both have square roots on them. So I can just do 6 divided by 3 with the square root all over the place. Not all over the place, all over. The square root of 6 over 3. And then 3 goes into 6 twice, so it just becomes square root of 2. And there it is. So the short leg is just square root of 2. If they wanted the long leg, they give you the long leg. If they wanted the hypotenuse, you would just double it, and it would just be 2 square root of 2. And that's it. And hopefully that was pretty simple, guys. All right, let's go to the last example here. I believe, yeah, that's the last example. So this is a 45, 45, 90 triangle, guys. So I write 45, 45, 90, and I put a little degree symbol there. I hope I did that earlier too as well. Yeah, good habits. And that property is n square root of 2. So here we go. We have one of the legs, it's 4. So that means the other leg must be 4 as well. And they want the hypotenuse. So this tells me that I got to multiply that 4 by the square root of 2. So it's just 4 square root of 2. So 4 square root of 2. And that's it, guys. I hope you enjoyed this video. It was short and sweet. And hopefully you guys took good notes. When you guys get a chance, try these out. This will be your first summer assignment. Notice the due dates. Hopefully I'll have another video before then with the second assignment. And I'm just going to keep adding to this summer packet, guys. So if you want to hold on to it, you can. If you don't have internet access, you can go ahead and just do these questions down here. And I guess, if you don't have internet access, you're not going to be able to see this video, right? So let someone know or let me know. Send me a group text DM solo or whatever, and just tell me that you don't have internet access and I can provide you a hard copy. All right, guys. I hope you guys had fun. I hope you guys had a good time. Give it a thumbs up. I would really enjoy it. Oh, I would really appreciate it. And I guess if you didn't like it, you can give it a thumbs down as well. But I hope that it's a thumbs up. And I'll see you guys later, guys. All right, later. Bye.